Hi everyone, one more final example from how to hypothesis test for proportions. This is example number 4, and we have from past records, a hospital found that 37% of all full-time babies weighed more than 7 pounds 2 ounces. This year they took a sample of 100 full-term babies, and they found 23 of those weighed over that 7 pound 2 ounce mark that they have. At alpha equal to 0.05, is there enough evidence to show that the percentage has changed? So again, our 5 steps. Step number 1, we write the hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis, we are talking about a percentage or a proportion. And our percentage started at that 37. That's the kind of the known, the norm, the old number that we had. And they want to know if there's evidence to show that it has changed. So changed means not equal to. Step number 2 is to look at my n p0 and that n times 1 minus p0 to see if we really should continue. In the last video, we shouldn't have continued, but we did anyway, just for practice. But in the real world, they would have actually looked at the data a little bit harder and to see if there were any outliers or if there were any, if it was kind of symmetric. And if it had been symmetric with no outliers, they still would have went ahead and done it. So in this case, we have our n, which is the 100. Our p0 is that 0.37, which gives me 37. Here we'll take that 100 times my 0.63, which gives me 63. Both of those are bigger than 10. So we can use our z-test to keep going forward. Step 3 is to find our test statistic. So the formula for our test statistic is as follows, and we've seen this a couple of times now. So there's our pieces. So we had 23 out of the 100, so p hat is this 23 over 100, which is 0.23, minus my 0.37, all over 0.37, 0.63, and my n was 100. Okay, so 0.23 minus 0.37 divided by square root 37 times 0.63 divided by 100, and I get a negative 2.899, so 2 decimals would be 90. Okay, step number 4 is our p-value. So our p-value is going to be determined by the fact that this is a two-tail. Okay, so two tails. So we're going to have 2 tails. And we're going to look at 2.90. Negative 2.90 is 0.0019. So here we have 0.0019. Since we have a two-tail, we will also put that here. So our p-value is going to be 0.0038. So I'm adding those 2 tails together to get that p-value. Step 5 is to make our decision. To determine what we're going to do is we find that our p-value is less than the alpha. So we will reject. And it is just a coincidence that all 4 of our examples did reject. Does not necessarily mean that always happens. But for us, we now showed that there is enough evidence to show a difference in the proportion of full-term babies that weigh more than 7 pounds, 2 ounces. All right. We have one more section for this unit. It's going to be coming from Module 18. And in that one, we're going to be continuing looking at proportions, but we're going to not look at just one group, but actually two groups, like proportion of men versus the proportion of women, or the proportion of young kids to proportion of older kids. So looking at two completely different populations and seeing how they may differ or not differ. But that's to come in Module 18.